Thank you for the very lovely introduction. As our lovely MC mentioned, my name is Kelly Fisher. I'm a senior Passive House consultant with Peel Passive House Consulting. I live and work here in Nova Scotia. I just have one of those fancy remote jobs that allows me to work from home. So it's always nice to share my experience with Passive House with the community in which I live and work, and to kind of share my knowledge with the standard to anybody who really wants to learn. So I am always keen to talk about Passive House to anybody who will listen. So thank you, Lori, for asking me to speak to you all tonight. So just a little bit of a background before I get into my session. So at Peel Passive House Consulting, we do everything Passive House. I like to joke that I eat, sleep, and breathe Passive House because it's all I do for work. And we go in a variety of different kind of categories across the Passive House industry, from training, certification, consultancy, component certification, and a lot of research and development. So everything to do with Passive House, which is very nice and refreshing. So for today's agenda, I'm going to be sharing some tips and tricks that I've learned over my years with experience of helping to get design teams to certify Passive House projects. I've kind of tailored it down to like the 5 principles of Passive House to kind of make it a bit more common and a bit more, I've tried to not get too technical with things. So I've tried to kind of break it out that way, and then talking about some energy optimizations that we typically want to employ in our buildings, and then a bit of a summary of how we can kind of come together with all of these different options to get what we want, which is certification, hopefully. So for the first kind of principle of Passive House, we're looking at our air barrier. Everybody knows generally that we're looking for a continuous air barrier. But what we often run into is people getting kind of sticker shock with some different pricing and different products, and even unfamiliarity with switching away from what they're used to. And when we're talking about trying to use more conventional building products or more competitively priced products, because when we're always trying to kind of look at our bottom line and how much it's going to cost us to build these products, or these projects rather, we've had some success over the years with various different more conventional products. So we've had a couple projects use the Suprema Stick VP, we've had the Henry VP 160, and then I've got a project here on the very right-hand side, I guess, yeah. It's a single-family home where we used Nova Wrap, which is a product local to, I believe it's made in Truro. It's my brother's house, and he ended up achieving less than 1 ACH by using that product on the inside of his house. We did all the hydrothermal modeling to determine if he had condensation risk, and it all kind of came out really great. So we're hopeful that's going to have long-term results, which is very exciting because it's a very, very economical product to use. Next up on our principles is insulation. And regardless of where you are in our part of the world, you're going to need a lot of insulation to meet Passive House standards. But one of the things that we always kind of look back to and what we compare to when we're doing our analysis for consulting work is we relate any design change to what is that equivalent to in an inch of insulation. So if you have for example, you want to change different windows or you want to change a different installation, it all kind of comes back to what is the knock-on effect with, do you have to increase your insulation, or if you've improved performance, can you actually reduce your insulation? So I've got some really cool examples about how we were able to kind of work through some projects and actually reduce the amount of insulation we had in our envelope in multifamily buildings based off of other optimizations we were able to make. And here's one of those examples. So the biggest impact that we find with insulation is with your space heating demand. And for Passive House, this is essentially the amount of energy you're going to be using to heat your building. And what we were looking at here is through various different levels of insulation, kind of the relative R value based off of, cladding clips and steel studs and that kind of thing. But also the difference of insulation and its conductivity has a huge impact on what you can achieve for your space heating demand. So it's kind of important, we find early in design, to carry maybe a little bit more insulation than what we think we'll end up with, just so we have that in the budget or for our model, if we're working with a newer team, for thermal bridging and that kind of stuff. But it just kind of speaks to the amount of insulation and also the size of your project. We find with larger projects, you can actually use a little bit less insulation on your walls and still achieve Passive House standards and still achieve your thermal comfort. So I had a 10-story building go up in Windsor, Ontario, and we were able to use EIFS with a 6-inch insulation thickness and still achieve Passive House standards. We didn't have to do 8 inches or 10 inches of insulation. So it was kind of impactful. The larger your projects, the more flexibility you have with this. It's not always going to be 10, 12 inches of insulation. Next up is thermal bridge free. This is thermal bridge design in a lot of projects is what we find can kind of bake in extra costs. If you have a really complex detail or really unthought out or unsequenced detail when you're looking at bringing in different trades at different times, or somebody has to come back after they've already been there, it can be really kind of adverse to the overall budget costs and construction. So we're always trying to make sure that everything is as simple as it can be. Here's an example of something that is not simple. This has 4 different types of insulation in it and a lot of different things going on. As you can see from the thermal image though, it performed really well thermally, but how anybody would ever build this on a budget, I have no idea. So we always try to make sure that we're doing something as simple as possible and we're being mindful of the sequencing. So when people are going to be on site, what their jobs are, what their trades are, and we're not having them come back or overlap with each other. And we always work towards making everything sequenced. So if it's a project team that hasn't done a passive house before, we want to make sure that everything is spelled out simply. So we're using color coding in our drawings and our detailings to show you have this sheet membrane, or you have this dashed line represents a different type of tape, and all of that is very clear. So whoever's building it on site knows exactly what they have to do, and everything is sequenced for the order of operations. So when people show up, different trades show up, we know what's happening. 4th principle of Passive House is triple pane windows. This is a big one that we find because some of our projects, and a lot of my projects, are multifamily social housing projects. So the budgets are really tight. There's a lot of funding incentives that these organizations are working with and very limited kind of capital costs for the initial investment. And what we're trying to do is source something that works from a performance standard, but also works from a cost standard. So I had one project that priced, I'm just gonna go back one. I had one project that priced 10 different window suppliers and ended up with like what they presumed to be the most economical, but then they ended up with more problems down the road. So it's not always about the cheapest, most cost-effective solution. One of the things that we find also with respect to windows is in passive house buildings, cooling now becomes our dominant load. So we've made this really airtight box, it's well insulated, we've got a really continuous layer of insulation, we've mitigated our thermal bridging, but what happens to the heat that we generate in our buildings? Sometimes, and especially in high density multifamily projects, we have a lot of people come with equipment, laptops, televisions, whatever, and they're also going to be cooking, and even just being in a building as a person, and in this room, I'm sure, you walk out to the windows, it gets a lot cooler because there's less people over there. But what happens is cooling becomes our dominant load. So what performance properties we're putting into our windows can sometimes be really impactful for helping minimize our cooling systems. So typically you'd find on like a single family home, you might have different glazing ratios on different elevations, depending if you're south, east, or west. But in some projects and multifamily projects, we're finding that this is really beneficial to help decrease our cooling system. So maybe we're able to go from a 1-ton unit in a 3-bedroom suite to a 1/2-ton unit for cooling in these suites. So it kind of has this economy of scale where we're able to drastically reduce the cost for the mechanical systems by being mindful of how much heat we're letting into the building. And here's an example with different window suppliers for a project that we tested where we looked at, this is only 3 of the 10, but we looked at different performance values and the impact on the space heating demand. Ultimately, the project went with the Aluplast product, which is imported from Europe. The other 2, Initech and Inline, are Canadian-made windows, but the Aluplast product had a bit better U-value for the glass. European glass is like that. It's a little bit better than what we can get here in Canada. But you can see the difference that it makes on our space heating demand. So for example, if we went with a better performing window, we could in theory reduce the amount of insulation we had on the outside of our building, which in this case we did. We went from 10 inches to 8 inches. And the last principle of passive house I want to speak to is ventilation. Ventilation sizing in passive houses is very important. The amount of airflow we move within our buildings has a direct knock-on effect with our space heating demand, how much energy we're using, and making sure early enough in design that you're sizing the amount of airflow you're providing to each building or each part of the building is very important. Because if you optimize that as best you can, then you have the capability to find the optimizations in other places. It's a very arduous process. I have lots of calls with mechanical engineers on this process. So here's an example through design for a 4-story building where we went from, so the ventilation air change rate, I'm going to use this lovely pointer. Ventilation air change rate is what the mechanical system is providing for the whole building. So how many times, it's kind of like your blower door test, right? How many times of air, or how many times the air is being changed every hour. So early in design, we're carrying 0.6, just because we know with the coordination with mechanical engineers, we might end up somewhere around there early in design. But as we kind of work through and we push them further to help them understand that, passive house buildings, we don't need to have that much air coming into our building because we have a much better envelope. So what we're looking at here is the difference in the impact that your air tightness or your ventilation air change rate has on your project. So because of this, we were able to decrease our exterior insulation from 10 inches to 7 inches, which is a huge cost savings on a 4-story project. So some of the impact of early passive house design, we always say bring everybody in as soon as you can from the onset, because these are the ways that you can help mitigate costs. If you have a passive house consultant or even a certifier brought in earlier enough on, they can help you understand where these optimizations can be found and help you work to a way to achieve your levels of insulation that fit best, or your ventilation rates that fit best, or even your windows. And that can really be impactful for the overall cost to help keep everything on track and on budget. So it's a game of knobs and levers. I like this slide. Any of you who've done the CPHC course have probably seen this at some point. This is all it is. It's like you're testing your window performance, your insulation values, the type of insulation, and you're seeing what works best. It's not a one-stop solution for everything, but we do need to look at everything holistically for the whole building. And some of the optimizations that we've employed are things like air admittance valves to reduce the amount of thermal bridging we have through ventilation stacks. We've P-trapped rainwater leaders that come out of the roof from roof drainage. We're looking at simple ventilation strategies, simple detailing, and we've gone so far as to most recently get funding from CMHC to help us come up with a combined domestic hot water heating and cooling solution. So that's going to be something that we're putting through an implementation phase at Peel Passive House as part of our research and development. So we'll be having a lot more to say about that in the coming months as we're more publicly allowed to speak about it. So in summary, bring your passive house person on as soon as you can. It is very, very important. If you want to keep everything on budget and you have those design kind of must-haves, you have to be able to kind of work in that tolerance. And that's it. There are no questions. Ignore that at the top. You can find me after.